It is Thursday, January 22, 11:08 a.m. Apparently tomorrow it's going to be like negative 300 degrees or something. I'm in refactor hell right now, but it's kind of fun. Here's what I'm doing. I have the main branch here. It says shape up top, and then on the other window I have this refactor separate work tree. And what I'm doing is I'm putting the whole app in one file. I wasn't kidding about that. Like I said in my last video, I'm putting everything in one file. It needs to be that simple. And that's what I've done. I've created this file called entity service. Well, it should just be called entity. It's not a service. I'll rename this. But what you have here is just a bunch of use case classes. So it just, imagine you had an entity service and then you had functions, instance methods like entity service dot sync, entity service dot, I don't know, get wrapping key, unwrap entity key, initialize workspace, create entity, index entity, search the index. But instead of one mega object, well, why not have single use classes for each concrete use case? And that's why it's called a use case. And so this way, you say something like decrypt entity with key lookup. You look at it and you know exactly its bounds. A use case can only have one function called execute, and it returns a result object. The result is, I like it better than try catch because it's more object oriented. And a result is very simple. It's just a wrapper around an error and a success value. And you look at this constructor and you can immediately tell, like if this was a service, this whole file is around 1500 lines. If this was a service, its constructor would have like 20 parameters and there's no way to tell what's interacting with what. Here, I know that when I want to decrypt an entity with key lookup, I need two dependencies. I need to get the wrapping key and I need to decrypt an entity. And that's all you in the execute. It's just very simple. I mean, there's no minimum as to how short it can be. The shorter, the better. And so let's say I want to index an entity. I'll just take in the dependencies. So what I'm doing is, so this is the whole app engine essentially, but there's a little bit more. So what I'm doing is take a look at the old file service, right? So we have something called the file service. Now files are a little different from all the other models because it's not just basic CRUD. It's actually like a chunking and blob storage. So this is the old file service. You see all these dependencies again. You have no way. I mean, look, to interact for the file service to function, you need the entire SSE connection manager. You need the entire key service. The key service gives you access to like delete all keys. So when you look at the file service, there's no way to tell that it won't accidentally delete all keys by calling the wrong function or something. So this right here is a huge code smell, but it's typical. What did I just do? I collapsed the whole thing. So within the file service, you have a bunch of these functions. Index file. These are private functions, but if we were to take a look at some of the public functions, so you have upload file, and you just take in a bunch of ordered parameters, and you do a whole bunch of stuff. You access a whole bunch of services. God knows what's going on in this function. I have no idea if it's accessing the key service. I have no idea if it's accessing the SSE service. And it calls another function that I have to go look into and see what it accesses. And then you have this function, looks very similar to the one above it. So what I'm doing, here's a pattern that I've decided to go with. Instead of a file service, create a file called files. So now I'm going to switch to my refactor. And I'll open up the file. I haven't renamed the service yet, but I'll do that now just so it's clear. Reveal, and I'll just rename this to files, right? So this is everything related to files. And here's how it looks now. It's just a bunch of use cases. There's no single object. So you have request single upload part URL, record so upload encrypted chunk. You know exactly what it takes. You can make a workspace request, you can encrypt the chunk, and you can request this. So it tells you exactly what this is going to do. There's no surprises. And then in here, you take a named parameter list. So there's absolutely no chance of making mistakes. And it's just so beautiful. Look at it. It's so beautiful. Create a base file. Upload file takes in create base file. So then this way I can reuse create base file with upload file from stream. So upload file and upload file from stream are different sources, but both eventually want to upload a file. And it's just so pretty. It's so clean. I mean, if I wanted to, I could split this in separate files, but I thought, why not? I know the usual rule is don't export more than one thing from a single file, but in this case, I like this. Now, here's another thing that I did that I thought was I'm really excited about. So I'm collapsing everything to a single entity file for type. So right now this is messy, forgive me, but I'm just trying to put everything in one file. So all the models right now before. So if I were to go to I don't have to switch. But you see the models; these are all old stuff. There's like 15 different entities: paper comment, notes, folder, forum channel, forum discussion. They're all the same. They have all the same parameters, and the content is encrypted, so there's no special field on the server. I'm done with that. I'm moving everything to a single entity called a server entity and a client entity, and then you have generics based on the content. And so the encrypted content differs per entity. Like a paper will have a name and text, but a file will have a name and a MIME type. But it's all a single file. Now, let's say you want to query the server for give me all files which don't have a parent, or get me all files in this specific folder. Now, the new entity structure is I'm not going to have a files endpoint, more or less. Like it's just going to be an entities endpoint that can query all the different types. And here's what I've done. So I've created something called, I probably reinvented GraphQL, but I don't like GraphQL. So execute remote query, and you take in a bunch of queries. Now, a query is just, basic predicates, comparison operator, logical operator, and then you combine them and you can create really complex things. So here's a demonstration. Let's say you want to fetch standalone files, because some files can be attached to a task or something. And so you want to fetch standalone files. And so here's the query. You want to get entities where the entity type is file and the parent type is null or the parent type is folder. And here you've constructed this entity, and you execute it. Execute remote query is another use case, so dependency on that. So you go into this, and you see it's just so simple and modular, and it is so clean. So none of the server stuff is built yet. I'm still there's probably 3,000 lint errors right now. I'm just like really destructively just working through this, but I will be deleting hundreds of files at least. I think what I can do once I have the engine built with all types passing and the integration test passing, that is something I could give to Codex like overnight on like X high or something and be like, okay, here's the engine. It's flawless. The API is flawless. Everything's flawless. Update the client to use this new single entity model. I know right now you're used to dealing with 15 different models like papers and comments and tasks. But update it to use this new engine, which only exposes a single entity, and then tell it to also update the server to only use this and expose the endpoints that the engine is expecting. And I think it could do that, honestly, overnight. I did say wait for the integration test pass, but I just realized that's not possible until the server is built. So maybe the server first, get the integration test to pass, then do the client. So that's what I'm doing. I'm doing all this by hand. For 1 second, I felt a little lazy. I'm like, there was in the file service, in the new file service, I noticed that the upload file and the upload file from stream were like doing common things. And I was like, just told Codex, I put it on high. I'm like, what did I say? I said in file service, upload file and upload file should look very similar. Can they be combined? And I could have easily done it. I don't know. Just wanted a break. I was so tired. Not so tired, but just a moment of laziness. And he said, yes, they can be combined, but I don't think. And I was like, okay, do it. And it just didn't do it right. Like it named a file, it created an abstract class, even though everything else was been a use case. and it called it a workflow base. Like, what is that? Like, in a file of use cases, and then you have a protected create pending. It just didn't get it. It didn't get what was going on. Functionally, this would have passed test. That's what Codex and Claude will always do. Yes, functionally, they will pass the test, the test environment. They don't pass human scrutiny if you were to really dig deep into it. And so I told it, nah, don't create a abstract class. Don't extend compose. Make it composable. So then it re-extracted things, and it was just wrong. It was just like, so I was like, all right. I went in. I did it in like 3 minutes, honestly. Like, so yeah, that's one. Two is I checked out Antigravity because the autocomplete model in Cursor sucks. It is so bad. And I was like, okay, let me try out Antigravity to see if the autocomplete is any better. And actually, it is pretty good. The autocomplete, let me open this. The autocomplete is more like what you would expect if you were to ask a separate model window to like solve the problem. Like Cursor autocomplete just fills in like 5 lines at most. Antigravity will think for like 10 seconds before autocompleting, and it will fill out. Like I've seen it fill out like 50 to 100 lines or something, and it's not bad. And so let me try to demonstrate. If it doesn't work, I'll cut this. So if you see a cut here, just try to imagine that everything just went to hell. So here's let's say I want to extract. So this is the main branch. So it's still the service based approach. Let's say I want to extract upload encrypted chunk and persist part to a use case. And so I'll start writing the use case. I'll say export class, and I'll call it use case here just so it knows what I'm trying to do. Actually, I need to first show it a use case. So let me open up a delete entity use case. Let's see, delete entity use case. Oh, and it's really slow. Antigravity is really slow to like navigate around. I don't know. I don't know why. Okay, so I'm showing it a use case here. This is a horrible example, actually. But okay, it gets the idea. Let me also open up a use case interface. Okay, so just opening the file, it'll put it in its context. So now I've done this, and I'll say extends use case interface. So let's see what it. Okay, it's still. It's too many dependencies, but okay, I'll just hit tab and I'll say execute. And okay, well, in this case, I think this is a bad example because this file is not ready to be extracted into use cases, to be honest. But needless to say, I do find. Let me see if I can. Okay, so we have an upload file function, and we have an upload file from stream. Let's pretend like I deleted upload file from stream. All right, and I wanted to fill it in. Now, it might be in its context, so I don't know, click around. And, okay, so now okay, it's drunk. It's drunk, the use case doesn't exist. Okay, look, I swear to you, yesterday I was playing with this, and it was doing a much better job at autocomplete. And so, because I imagine it's using Gemini, like 2.5 or 3, Flash probably, and Cursor's autocomplete uses an in-house model. Like, why is Cursor training their own model? It's probably using some kind of open source model, open weight model. So, it's promising, but a whole bunch of things don't work in Antigravity. Like, I couldn't get prettier to format. It's up here, but when I run format, it formats some things, but I have a line width here that it doesn't respect, so things kept overflowing. So I don't know. Overall, I do think Cursor is the better fork of VS Code, but Antigravity is way better. Trust me on this. Like, I can't show it here, but I would say at least 10 times better autocomplete. A little bit slower, but I want it to be slower. Like I want it to be a little slow. Like I wouldn't mind if Cursor just slowed down and it gave me better suggestions. And I have it on auto. It's only fast and auto. It's probably the same thing. But it's really bad. The cursor autocomplete model is really bad. I do think developers are going to start going back to autocomplete very soon once the AI bubble, not bubble, the AI developer bubble, that's going to pop. Like the AI thing, oh, we're just getting started, like technology wise. Like, I don't think that's a bubble. But the AI developer hype bubble of like AI writing all our code and humans not having to review it, that's going to pop and that's going to be painful. And in the short term, I think that a lot of developers might lose their jobs because people are thinking that AI is going to write the code. Give it a year or two, and the demand for developer jobs, I think, is going to skyrocket. Like you need you need humans writing this stuff because the AI just has no idea what it's doing. It really just doesn't. I mean, that's not a surprise. It doesn't know what it's doing. I mean, the internal representation is just numbers. Like it looks like numbers to it. Which okay, it's emergent. We don't really care what it looks like to itself. It's like, what do our thoughts look like to us? It's like neurons. Okay, fine, fine, fine. But at the very least, our consciousness reasons with like real symbols that like are like, I don't know. I'm getting philosophically, but it's like physical in a sense. It's I don't know. It's like abstract, but it's real. Whereas, yeah, AI is just reasoning about statistical relationship between numbers, and the numbers map then to tokens, and the tokens are combined together to look like English to you, and that's what you get. So yeah, there's no internal understanding. There's just an approximation, and the thing is that software was already an approximation. Software is an approximation of intent. It's an approximation of a vision a product manager or entrepreneur has in their head, and they translate it to code. So it's already an approximation of an abstraction, and then when it's very and it's already lossy. Now when you go to AI, you're putting this middle layer where we're now having to think in English, which is usually developers will think in code. Actually, will think in code rather than English. A little bit of both, but now we have to think in pure English. We give it to this lossy approximation engine called an LLM. It approximates our intent, and then it approximates the deliverable. And what do you think the result is? It's an approximation of an approximation, and you lose detail all the way down. And I think, given that everything comes from humans, as no matter what, no matter how great the technology is, as long as you introduce a middle layer that translates from human to middle to result, it's always going to be lossy. That's just fundamental. And so if you're a developer and you can code, that's always going to be, don't listen to the hype tweeters on X. If you can code, it's going to be really valuable. And actually, the 20-year-olds right now are not learning how to code because they're too busy like vibing. And so when the developer bubble crashes in 1 to 2 years, once all the technical debt just becomes staggering, the only people that will know how to code are the people that learn how to code before AI, before 2022. So I think developers are probably going to be extremely highly paid, even more so in a couple years' time. So that is my thoughts on the matter. And either I'll upload here or I'll update later in the day if something happens. I don't know. I'll figure it out. Thanks for watching.